Alright, in this video we're going to continue on our discussion of power series, geometric power series specifically. So we're going to be able to differentiate power series to find other power series. So use power series for f of x, so 1 over 1 minus x. On the previous page to write a power series for f prime. So in the last video we looked at this function. That was the first function we looked at. So that was, if we remember, we go back and we look up here. This 1 over 1 minus x is this power series. So we can go ahead and we can think about that. Okay, so we know f of x is 1 plus x squared plus x cubed and so on. Alright, so now f prime, all we have to do is take the derivative of our power series, which is really nice because this is a polynomial. We know how to take derivatives of polynomials really well. And that's one of the big ideas behind a power series, why we have power series, is so we can easily take the derivative. So derivative of 1 is 0, plus derivative of x, we have 1, plus derivative of that, and then derivative of this, and we can continue on down the line, but that's essentially it. That's what we're looking for. Okay, so in 7 here's j of x. If they give us a power series right now, finding j prime, that's all we're doing is taking derivative of each one. So j prime would be 0, 1, so 0 plus 1. And then derivative of this would be 2x over 2 factorial. We're going to be able to simplify this in a minute. So if you see it right now or know how to simplify, you can go ahead and do that. But we're taking derivative here, and 4x to the third over 4 factorial. Okay, so we can do this if we want to. We don't really have to, but we'll just say this. And so we get comfortable writing this. So we'll drop the power down to the front and then subtract the power. So that general term is going to be this. Now, this is equivalent, like I said, we can break this down. So 1 stays 2 over 2 factorial. Well, 2 factorial is 2, so that would just turn into x. And then the 3 over 3 factorial, we know 3 factorial is 3 times 2 times 1. Well, if we cancel 3's, then it's just 1 times 2. So that's going to be 2 factorial. So we end up with x squared over 2 factorial. And then the next one, 4 over 4 factorial. That's not 4.1, that's factorial. I don't know why that shifted over like that. So 4 over 4 factorial, the 4's cancel, and we're left with 3 factorial. And then the general term, we could simplify this. The ends would cancel, so we're going to be left with, think about what the next smallest term on the bottom is for n factorial. We've worked with that a little bit. That's going to be n minus 1 factorial. And then x to the n minus 1. So if we can see, if we look at what we just wrote, because the next part is asking, can you identify the function j of x? So j of x is given by this, and j prime is this. Okay, so let's look at what we just got. So if we look at the terms, they're all the same. Okay. So what function has the same derivative? So I want you to pause and think about that. So j of x is going to be e to the x. Because we know e to the x, the derivative of e to the x is just e to the x. Okay, so this power series represents e to the x. Alright, so now we're going to take a look at integration power series. Alright, so if we integrate power series, so they give us 1 over 1 plus t. So that's what we were just talking about in the last video. We talked about 1 over 1 plus x, but we're just replacing it with t, which is no big deal. Same thing, it's just a variable. So they give us 1 over 1 plus t is defined by this power series. So that's what we were dealing with before. Okay, so 1 over 1 plus t, we set it equal, and then we integrate both sides. Okay, so we're finding the integral of both of these, the power series and the function itself. Okay. So now if we integrate both sides, we know what 1 over 1 plus t is. That is natural log of 1 plus t. Okay. Evaluated from 0 to x. And then equals, we know what the integral of a polynomial is, so that would be t minus t squared over 2 plus t cubed over 3 minus t to the 4th over 4, and so on. And we are taking all of that and we're evaluating from 0 to x. Okay, so there's more terms here. We're just going to cut it off. So now if we evaluate natural log at x, we have natural log of 1 plus x minus, we plug a 0 in, we get natural log of 1, equals, throw the x in, so we have x's now instead of t's. Oops, I was going to write a t again. So everything's the same except the variables change. And if we plug in 0 to all of these terms, that's just 0. Okay, all of them cancel out to 0. So now we look on both sides. So natural log of 1, if we remember, that's 0. Okay, so let me write that there. Natural log of 1 is 0. So we get natural log of 1 plus x equals this. So we just found the power series for natural log of 1 plus x using integration. Alright, So now we can go ahead and we can do the same thing that we were doing yesterday, the substitution, finding power series by substitution. So in example 9, it says use the result of example 8 to write a power series for natural log of x. So we have natural log of 1 plus x. So we want natural log of x. So we need to think about how we can match those up. We talked a little bit yesterday how to do that. So if I want it in this format, because this is what I know, and I want it to turn into natural log of x, we need to do 1 plus x minus 1. Okay. 1 plus x minus 1. So now our input is not x, it is x minus 1. So we can go ahead and throw in x minus 1 for all of our inputs. So that first term turns into x minus 1 minus x minus 1 squared over 2, and so on. X minus 1 to the third over 3, and x minus 1 to the fourth over 4. And we can continue on in that fashion. So we just use integration to find natural log of 1 plus t. And now we use that to find natural log of x. So that's pretty cool. So instead of just remembering these power series, which eventually you probably will, and it'd probably make your life a little easier as opposed to running through all this work, because remember the main goal on the AP test, or when you're working through problems later in your life in higher end math classes, is to save some time on some of the simple stuff and utilize the time to think a little bit deeper on some of the harder things. All right. So last example for the video, and then you guys will be able to go and finish 7.4. So we're going to write a series for g of x, which is x squared times ln x. So we know what ln x is. We know what that power series looks like now. We just found that. All right. And well, let me add this to. I'm going to add this out front. I forgot to do this. Okay. Natural log of x is this power series. So all we have to do. So if we want x squared ln x, that's the function that we want. That's going to be equivalent to, and all we have to do when there's multiplication out here of a power series that we know, all we have to do is take our terms and multiply by this value here. So we're going to have x squared times x minus 1 minus x squared. Okay, so all the terms that we had up in the last example are getting multiplied by x squared. And I'm going to cut it off here. You can write that other term. I'm just going to cut it off there because you get the idea. So take some time, work on these. There are some tricky problems in here, but let me know if you have any questions on power series, geometric power series, and then we'll continue on.